Yo, what's up guys? So I'm back with another Minecraft computer video. As you can see, I have modified my computer quite a bit. It is now color-coded, kind of, and then it is a lot bigger. So I doubled the RAM and doubled the instructional memory. And as you can see here, I added a little display. And then I also added a few functions. So the first one I added was the jump function, or the loop function, where I can, in my step counter over here, I can jump to a certain spot. So I can jump to whatever step I want. And then we have this one right here, which is binary number 6110. That is my display function. So as you can see with this dark gray part out here, or this gray part out here, this is the display, so that's going to be the output. Just for now we're using it as a display. And then 7 is, I don't really have a name for it, but like the move function, where it takes the value of one memory slot, like one byte of RAM, and moves it to another byte of RAM. This is good because what I was doing before, when I was making my Fibonacci sequence, is I would save a memory slot, is just what I like to call it. I would save a 0 to that, and then whenever I want to move data from one slot to another, I would just add the slot to 0, or the slot that's worth 0, and then move to the slot, whichever slot I want it to be. Which the issue with that is that it would actually take up memory, because I had to reserve a memory slot with 0, so it would take up an unnecessary memory slot. So I decided I think a move function would be much more efficient. So this Fibonacci sequence is very, very simple. It's only 7 steps. First step, it saves 0 to the first memory slot. And then second step, it saves 1 to the second memory slot. So this is because the Fibonacci sequence automatically starts with 0, 1. And then what it does is it adds these two slots and moves them to slot 3, which it's the same concept, just add. So like the Fibonacci sequence, for those who are not aware, you add the previous two numbers in the sequence, and that's how you get your new number. So it would go 0, 1, which we start with, then 1, then 2, then 3, then 5, because 2 plus 3 is 5, then 8, because 3 plus 5 is 8, and then 13, because 5 plus 8 is 13. So it adds these two slots and saves them to memory slot 3. Then what it does is it displays memory slot 3, so I get to see what the next number in the sequence is. And as you can see here, this 111 back in the computer, you could see that this is the move function. So I'm going to move the value of memory slot 2 to memory slot 1. Then I'm going to move the value of memory slot 3 to memory slot 2. And then I'm going to jump back to step 2, which would go all the way back over here to the add spot. So it's really simple code. It just, you get a 0, you get a 1, you add them and get your next digit, or your next term in the sequence. Then you just shift everything over one to the left, and then you jump back. So you loop, and then you add, shift, or I guess display really. So add, display, shift, and jump back. So the reason why I expanded this, I doubled the instructional memory, is because for the Fibonacci sequence it took up 7 slots out of my 8 slots, which I realized was not going to last if I want to make more complex programs. So I just decided to expand it. And while I was at it, I also decided to expand my memory. And so this led me to expand my inputs as well. So as you can see with this blue part here, these are my inputs. Instead of having 3 inputs down here for my functions and 3 inputs here for my memory slots, I made it 4. And I guess when I say inputs, I mean bits. So instead of having the capacity for 7 functions, or I guess technically 8 functions, because I could have a 0 as a function, I can now have 16 functions and 16 memory slots, and now here's 16 steps. So it just makes it a lot better and able to do more. So one thing I wanted to point out is that I actually ended up switching my adder. I found actually a better adder design, which almost instantly does the calculations, and it was a lot better for my computer, because how my computer switches steps is it just tracks its input. So whenever it gets an input, it runs the next step. So what happened with my last adder is that it was very it was not very fast. And so what happened was it would end up sending false inputs out while it waited to fully calculate it, to fully process it. So it would actually end up triggering it too early, and that would just mess everything up. So this one basically instantly does that and has no false outputs. Okay, so you guys may be wanting to see the Fibonacci sequence now in action. So what I've done is, because my computer is very slow, I have turned up the tick rate to 10 times its normal speed, which is still pretty slow, but it takes a lot of time to process. So let's start. So right now we're at step 0, and I just flick this lever to get it started. So let's look at our outputs. So we have 1, so it already starts with 0, 1. Now we should see a 2 after this, yep. Then a 3, which is 1, 1. Then we should see a 5, which is 1, 0, 1. Just look at this black gray part over here. Then we should see 8, which is 1, 0, 0, 0. Then we should see 13, which is 1, 1, 0, 1. And then 1, 0, 1, 0, 1. And then I forgot. I think it's 1, 0, 0, 0, 1, 0. Yep. And I don't know any after that. So that is just a quick little peek at the Fibonacci sequence. It can go on for, I guess, basically forever, because it has the looping mechanism. The issue with this is that's an 8-bit computer, so whenever the adder adds a number that's larger than 8 bits, it just discards the highest digit or the higher digits. So it only really gives you the bottom 8 digits of the binary number. So that was my showcase of my computer. I'll probably be working on some other things, working on some more programs. If you guys have any suggestions for what programs I could write to this thing with its current functions, if you guys have any ideas, feel free to comment those. But that is about it. Peace.